Yes, class, written. See, this figure shows a cross section of light pipe made of glass fiber of refractive index 1.68. The outer covering is made of material refractive index 1.44 and TIR is occurring. So we have to find out the range of incident angle. Now see, here, if you will apply sin IC, because this is critical angle given in this case. So if you see at this moment, critical angle is there. So sin IC is equal to 1 by NDR. This is what we have studied yesterday. Correct or not? What was critical angle? I hope you all have revised and come. See class, two things we studied. Condition and critical angle. So conditions of TIR. Two conditions were there. First, light has to travel from denser to rarer. And secondly, angle of incidence has to be greater than critical angle. What was critical angle? Angle of incidence in the denser medium, for which angle of refraction in rarer medium is 90 degrees. Correct? Now see, this is what it is asking. What is the range of angle of incident rays? Why range? Because it has to be more than critical angle. That was one of the conditions. The angle has to be more than critical angle. So what is the range? How much more? That we don't know. That's why it is asking you the range. So basically you just have to tell the angle of incident rays with axis of pipe means angle of incidence. Now see, if we write like this, what is NDR? ND divided by NR, correct? 1.68 divided by 1.44. Fine. Now sin IC will be equal to 1 by NDR means 1.44 divided by 1.68. Correct? Now class, when you will solve this, this will be equal to 0.86. Alright, this is equal to 0.86. Now for total internal reflection to occur, the angle of incidence, no, let's say this is I prime. This has to be greater than critical angle. This is the condition we studied. Just put sin. Sin I is greater than sin IC. All right, class. Now see, what is sin IC? Have we not found the value of it? It is 0.86. So sin I prime is greater than or equal to, this is the range class. Please focus, this is the range. This is equal to 0.86. Am I clear till here? I prime is greater than I dash, IC. So sin we have multiplied. So sin IC is 0.86. So this is it. Now what is I dash? Firstly, what is I dash? If you look in here, what is I dash? I dash is this angle for which the TIR is occurring. Why am I writing it as I dash? Because main angle of incidence is this, for which the light ray is hitting the pipe and getting refracted. Clear class? So here the angle of incidence, that's why I'm taking this as I prime. Don't take this as I, otherwise you will confuse it with this I. Now I dash means this angle plus this angle of refraction plus this 90 degree, this small triangle. Can you see this small triangle that is formed? This is I dash, which is greater than critical angle. This is angle of refraction. This is 90 degree. Correct, class? So I prime plus R, this is equal to 90 degree simply. Right? So that's why I can write this I dash plus R equal to 90 degrees. So I dash is equal to 90 minus R. Now sin 90 minus R is greater than or equal to 0.86. What is sin 90 minus theta? How can I modify this? Sin 90 minus R.
Ma'am, cos theta.
Cos theta. Perfect, Fadil. So I can write theta here is R. I can write this as cos R greater than or equal to 0.86. Correct. Now see, cos R is this. What is the value of sin R? Because ultimately I require sin R. I need sin I need sin R. That's why I can find out the value of I. See class, let me repeat this. My purpose is to find out this angle of incidence. Right? It's not asking me the critical angle or the angle for which the critical angle is exceeding, nothing. This is asking me what is this. So for knowing this angle of incidence, I need to know this. I know the refractive index of this medium. I know the refractive index of this medium. I can apply Snell's law and find out angle of incidence. But the problem that is coming here is that I don't know this angle of refraction. Are you getting? If I know this angle of refraction, sine r, I'll immediately use Snell's law and I'll find out this small I, right? So the problem that is arising here is that I don't know the value of small r. Sine r is unknown to me. As soon as I'll find sine r, I'll be able to apply Snell's law and I'll get the value of this. Now what is happening, class? In order to find out, now class, what is happening? In order to find out this value, see, in order to find out this value of critical angle 1, here I'll apply Snell's law. Incident ray is coming, getting refracted. Simply apply Snell's law over this point, you will get the value of sine I, correct? Problem is that we don't know the sine r. We don't know what is the value of the sine r. So we can apply and use this triangle and the property of total internal reflection here, which is a hint given to us in the question, correct? For which TIR is this. We don't know what is the value. We know that TIR is occurring. So we can use this information to find out sine r. That's why I have done these calculations. This is an important question, class. That's why I'm repeating this. So if you are not understanding at any point, let me know. I'll repeat. Now look, sine IC I have found. Using sine IC, what did I do? I have come to the conclusion of sine r. Now I have the value of sine r, which is equal to under root 1 minus 0.86. A square of it. We write this, no? Sine r will be equal to under root 1 minus cos square r. So square of this. Now I have found the value of sine r. Do you understand why was I calculating and modifying this? Because I ultimately needed sine r. Once I have sine r, I'll apply Snell's law. See, when you will solve this, this will be equal to 0.26 sine r. I have sine r greater than or equal to 0.26. We'll take the minimum value that is equal to. It can be greater because range is given. Already the question is hinting you have to tell the range. You can write it greater, right? Now you have sine r. So sine I, class application of Snell's law. This medium refractive index multiplied to the angle that is formed here. This medium's refractive index multiplied to the angle formed here. So at this point, this is air and R, that is air is 1. This medium is air. So 1 into sine I is equal to 1.68 of this medium into sine R. This is the application of Snell's law. See, sine I will be sine I into 1. Medium, air. Refractive index 1. You have to remember refractive index of air. Air, glass, water. ये तीनों याद रखो. ठीक है? So sine I into 1. This is equal to sine R, which is 0.26. Refractive index was 1.68 into sine R. Correct? Now sine I have to find out. Is equal to 1.68 into 0.26 because the entire value of sine R is 0.26. So this becomes 0.436. This is greater than or equal to. So what is angle of incidence? Angle of incidence is greater than or equal to sine inverse 0.436. That's it. I'll repeat this. This is an important question. That's why I'm taking time. Now, we'll start with spherical refracting surfaces. TIR is over. All right, class. Here, you just had to find out this angle. a ray of light was coming. These are our outer and inner section. Class, wherever you're not understanding, please stop me for in this question in between. Fine. Now the light ray gets deviated. TIR is occurring. That is all given in the question. We want to find out I. We can apply Snell's law. 1 into sin I is equal to n into sin R. We don't know what is the value of R. So we use this triangle. We found sin R. Then we applied Snell's law. Now tell me, is it clear to all of you?
Yes, ma'am.
Only Fadil? What about others?
Yes.
Clear? Amna, Deborah, Rajita, Shahid. Shahid, clear? Rajita, Sidra.
Yes, yes, ma'am.
All right. Write it down. Wherever you get stuck, you can let me know. All of you have written the question. Wherever you get stuck. That's why I gave you sufficient time to try this question. Mark this as important. Okay. Now we'll do spherical refracting surface. Next week, we'll complete this lesson, ray optics. Next week will be taken. I'll tell you how many topics are left. We'll do spherical refracting surface. See, telescope, prism, optical instruments. These are all the optical instruments and lens maker formula. So this will take entire Saturday, Sunday complete next week, right? So let's complete that. Now then we'll start with wave optics. So for studying wave optics, the second batch, those who have their classes at 9 p.m. also, you also attend wave optics here. Because see, we are we are already completing the syllabus, the portion over there, right? So we'll go at that pace only so that we don't rush up or mess up things over there, but do attend the class only. So for some more time, you will have your extra classes over here. Attend the classes from here, wave optics only. Because now a link for optics has been made, let's not break it.
Excuse me, ma'am.
Yes, Fadil.
Ma'am, today in the second physics class, from where will we continue chapter 5?
Chapter 5, Earth magnetism is just left. Earth magnetism we'll complete and we'll start with EMI itself today
We'll
because
start a new chapter, right?
we'll start with EMI
Okay,
because
okay.
Earth magnetism, a very small portion was left yesterday, which I
Fine.
couldn't complete. Okay.
Yes, ma'am. Okay.
You have
Okay.
your class also, no, in between, Fadil?
Yeah, ma'am, I had my JE class.
So today also you're having it.
Yes, ma'am, I have it 6 today, every week.
Okay.
I'll watch the recording or something.
No, but it won't clash. Classes are not clashing, no, Fadil?
Ma'am, it'll start at 6 and it ends till 7. And physics class is 6:30 KSA time.
See, there's 1 hour gap in between both the classes, 8 to 9.
For physics, yes. And then in that gap itself, I have
Yes, that's what
chemistry
I'm
class.
saying. Classes are not clashing, no? You don't have to miss any part, no, of any class.
No, ma'am, the chemistry class and physics, it will clash. There's
Chemistry,
a,
physics, how?
ma'am, because 6 I have the chemistry class, right? And 6:30 the physics class will start. Chem class will be 6 to 7.
Okay.
I told the team already. They told they'll reschedule.
Okay, that's why, because I also heard that some classes are clashing because your JE classes also. Okay, I'll ask the team then only.
Yes, ma'am. Okay.
Because classes shouldn't clash, no, otherwise you will miss on parts.
Yes, ma'am.
Okay, class. Now, basic applications of TIR. This I will suggest you all to read it once from NCRT. All right. Usually, I tell nothing. Everything is written. Everything we discuss and all the notes are written in the class itself. This I'll suggest you. Why? Because this is an important topic. Questions are there from this topic, and it sometimes happens. No, we are not able to explain the thing properly, which we have understood it well. So basically, you will get words from NCRT to write. And these application based questions do come from the TIR portion. All right. Now, first application of TIR is mirage, formation of mirage. So mirage is basically optical illusion. This is not an actual phenomena which is occurring. It's an optical illusion. Just a second, class. So this is optical illusion. Now, basically, here what happens, light travels from denser to rarer medium. Now, obviously, एक चीज है, whenever you have to write about TIR, one point you will always have in your hand, that is the condition. To write, at least you will be able to write, if nothing, at least this much, that light rays will travel from denser to rarer medium. At least this much you will be able to write. So denser to rarer medium, the light rays are traveling. So what happens here, because of different layers are present of atmosphere, refractive index basically increases in this manner from the ground upwards. When you are going towards higher altitudes, here the refractive index is increasing. So refractive index increases at this point when the temperature is decreasing. This is just for your remembrance. This happens. So because of different refractive index, what happens? Light rays are traveling from denser to rarer medium. So at every point, light rays are getting refracted. Light rays are getting refracted. Again, light rays are getting refracted. Like this is occurring. So ultimately what happens is that TIR occurs. That angle of incidence, like the cases we discussed, no, 4 cases. Initially, it is bending, bend, 90 degree, critical angle reach, greater than critical angle, TIR. Same thing will occur at a point. Now, because of TIR, what will happen? Suppose this light ray was to be refracted and light ray would have passed straight away. Here, what happens? at the same point, because here TIR is occurring, total internal reflection is occurring. Here what will happen, the light ray will be deflecting, it will be getting totally internal reflected, and here an image will be formed, which is not an actual image formed. You must have heard of this. See, on very dry heated areas, very dry heated roads which are present, uh, you will see that water is present at a certain distance. Actually, it's not water, it's optical illusion. Basically, mirage formation occurs. The reflection of sky is there, which seems like water. And when you will go near the water surface, whichever you were seeing, you will not see anything. You will see simple, dry, hot, humid road is present. So these are certain applications. That's why I'm saying just read about mirage formation. This is one. Second one, brilliance of diamond. I think, yeah. Second one is brilliance of diamond. See, brilliance of diamond basically means you have seen diamond, sparkling of diamonds you have seen. If you see a diamond, diamond sparkle. So here what happens, suppose this is a portion of diamond. Once light enters, so a critical angle for this diamond is almost equal to 27 degrees. Once this angle is reached, no, light rays will enter. And once they enter, here TIR occurs, getting reflected. Again, here at this surface TIR occur, they'll get reflected. TIR occurs, this surface. TIR occurs like this. So that sparkling which we see, it's actually because of total internal reflection, all the light rays are moving. You must have seen, even if you take a very glittery surface, right? So diamonds are also like this. They will glitter, they'll shine. So that brilliance, that shining or sparkling of diamonds is because those light rays, they are getting internally reflected from all the walls. Fine. So this is one example. So refractive index increases, small critical angle, light traps. I have just written words. That's why I'm saying do read it from NCERT. Totally reflecting prism. See, for prism, angle of refractive index is 1.5. Glass prisms are what? Glass is 1.5. And critical angle for prisms are 42 degrees. Fine, when we have normal simple prism. Because this is found using this only. You take it as sine inverse 1 by 1.5 and all. You will get this. This value, remember this value. Straight away, when you have the value, just remember it. Now, how the reflection of light rays occurs. This part can be asked to you separately to draw. TIR is important in itself. That question also which we had seen with which we started the class. It was a very simple question. You have seen the solution. The solution was very simple. But see, if you don't know the solution, initially when you see that question seems a little difficult. Right? Initially, that question doesn't seem so easy. So the questions of TIR are like this only. Calculation part is very easy. You just have to apply Snell's law. Simple multiplication, division. But the correlation is difficult. That's why I'll suggest you all to practice more and more questions from total internal reflection. More than anything else. You will be able to solve all the questions of mirror formula. Formula-based questions are there, magnification. You will be able to find it out. The next part that we'll do, spherical refracting surface, that also you will be able to do. But total internal reflection, whatever questions, most of the questions that I have seen, they are not so direct. Means the solution is very simple. But unless and until you don't know the solution, you don't know what's the first step, from where to start. So practice, the only solution to this is practice. Practice whatever doubts you are having. Let me know. I'll arrange doubt classes for this specifically. Fine. Are you understanding or not, class?
Yes, ma'am.
See, reflecting ray of light by 90 degrees. So this is a right angle prism, means this is 90 degree, this is 45 degree, this is 45 degrees. Now this is an object, suppose. AB, this is an object. So what is happening? Light rays are moving. At this particular point, TIR will occur. Means a critical angle, it will cross 42 degrees, critical angle is reached. So because of total internal reflection, light rays will get reflected. So what happens? The image that is formed This is A dash, B dash. Can you see initially it was like this. Now it is like this, 90 degrees. This is how reflection occurs by 90 degrees. Now, when we have to reflect it by complete 180 degree. So for 180 degree, you just have to shift the prism. For this, this is 90 degree, 45, 45. Now, here keep the image, object, sorry. AB, this light ray will go, light ray will go. They will get totally internally reflected. Now at this surface also they will get totally internally reflected. I have not drawn it properly. Please draw it with the help of scale. And in the exam, though, just keep your protractor and scales ready. These types of diagrams won't work here. I'll draw it properly otherwise if you need. This is B dash, A dash. So see, complete inversion. This was the object. This is the image. Complete inversion occurs like this. Last application is the application of optical fibers. Basically, in case of optical fibers, the way that question we have done, that was a question based on optical fiber only. In that, we could use and apply TIR. So similarly here, what happens? Concentric layers are present. Outer surface is there, inner surface is there. And inner and outer surfaces have different refractive indices. So from denser to rarer light ray will enter, it will exceed critical angle. So total internal reflection occurs in optical fibers. In optical fibers, best example is optical mouse. You have seen optical mouses, red color light is present. Optical mouses, the wire that is used, those are optical fibers only. That light that comes is because of TIR. These are some examples, some basic important examples from which questions have come. Write it down and do read it from NCERT also. Yes, Tarif. See, optical fibers, you just have to remember when the light ray enters, because here is a difference in the refractive indices. This is denser medium, this is rarer. So total internal reflection occurs. So like this, because of reflection occurring at every surface, light rays keep on traveling. All of you written till here, can we start with the next topic? Refraction from rarer to denser and denser to rarer. See, spherically refracting surfaces means what? Mirror is one thing that you have painted on one surface and reflection is occurring, right? But what if I just take a portion of the circle of that hollow sphere? If I just take a portion of it, so a reflection can occur from both the surfaces. Now here what will happen? If I paint one part, suppose this is a hollow sphere, fine. Now I take this portion of it and I have painted this side. So what is happening? Reflection will occur from this portion. This is how reflection occurs. But if I am not painting this surface, I am not polishing this surface, so what will happen? Both the surfaces are free. So air is one medium is glass. So which phenomena will occur now? Now reflection, instead of reflection, refraction will occur. Clear glass? This is a hollow sphere. I have taken a portion of hollow sphere. And now I have left it. I'm not painting on, I'm not polishing it for reflection to occur. Correct? So these spherically refracting surfaces, we have to study about them. So likewise, if I take this portion, this acts as a convex surface. This acts as a concave surface. Where the denser medium is closer to the surface, that is convex, outer one is concave. Now, object distance is present. You have image distances. You have radius of curvature, and you have both the refractive indices. One for the glass, one for the medium outside. So what we will study? We will study their relation. We just have to establish a formula to relate all these. Fine. So refraction can occur from rarer to denser medium or denser to rarer medium. Means, first case, when the object is kept in the rarer medium and the image is kept in the denser medium. Fine. Here the image is kept in the denser medium. In the second case, what is happening? The object is kept in the denser medium and the image is kept in the rarer medium. Fine. This is occurring. So in both the cases, we have convex mirrors, concave mirrors. Convex mirrors, concave mirrors. Surfaces maybe. So here, in all these cases, we get real and virtual images. This you have to remember. Whether our object is in rarer and we are talking about concave convex, or object is in denser and we are talking about convex and concave surfaces. Now these two derivations are important for you to remember. Refraction from rarer to denser medium. Now just understand the figure. The next one you all will tell by yourself. So this is a portion of the mirror that the surface that I have taken. Suppose object is kept here. So this is what? This becomes the incident ray. This is the incident ray. Now, whenever you have to draw normal for any circular part, whether it's hollow sphere, whether it's mirror, always remember for this surface, no, whenever you're dropping a normal always passes through the center of curvature. Suppose this is center of curvature. So this is the normal with this incident ray. This is angle of incidence. Clear? Incident ray, normal, Why normal? Because this is passing through center of curvature and this is angle of incidence. Fine. Now refraction will occur. Suppose at this surface refraction occurs and an image has been formed. Here an image has been formed. This is not joining. This is actually formation of this bending of this. So this angle is angle of refraction. Now some more angles I'm taking just for derivation purposes. They don't have any significant value, just for derivation purposes. I'm taking this angle as alpha. Okay, this angle is alpha. I'm taking this angle as beta and I'm taking this angle as gamma. Fine. This is the pole of the mirror P. From the pole of the mirror, this is object. So this is object distance U. This is center of curvature. This is pole. So this becomes radius of curvature. And this entire, this will be image distance. Clear? Let's say the refractive index in this medium is N1. On this side is N2, which we are going to use. Also, one more thing. For the calculation purpose, no, I am dropping a normal because I require this triangle. I have dropped a normal, let's say N. I require this triangle for the derivation. So this is N, a perpendicular I have dropped. Let's say this is M, this is N. Now at this point M, if we apply Snell's law, N1 into, what is the angle in the N1 medium? I. So this becomes sine I is equal to N2 into, at this point when you are applying, the angle is sine R. Fine, sine I. Now see, small angle approximation basically says your tan theta or sine theta, both are approximately equal to theta. So you can write sine I also equal to I, you can write sine R also equal to R. So when I'll write this, so this equation will become N1 I is equal to N2 R. Fine, keep this equation. Now if you look at this triangle, this one, this bigger triangle, if you see, can you see I is the exterior angle for this triangle MOC. I is the exterior angle. There is exterior angle property which you must have done it in your 10th standard, which says that exterior angle of a triangle is the sum of the opposite angles. Do you remember? Is it true or false? What I am saying?
Yes, ma'am.
Right?
Hmm.
Others. Only Fadil is active today. Keep on responding. Either I give you full liberty to write it in the chat column also. I don't ask you all to open your mic all the time. Fine. So just keep on responding. So I at least have an idea you all are understanding or not. Yes, the exterior angle property of triangle says that this exterior angle which is present in a triangle, this is equal to the sum of the opposite angles of the triangle. So in this triangle, in triangle OMC, I is equal to alpha plus R. Clear? Similarly, if you see this triangle, this small one, MCI, can you see R plus beta is equal to gamma? These are the opposite angles and this is the exterior angle for this triangle MCI. So for this triangle, this derivation is very important, class. In triangle MCI, gamma was equal to R plus beta. So R is equal to gamma and this will be confusing. Gamma is equal to R plus beta. So R is equal to gamma minus beta. Now we have the value of R. So N1 into I, what is I? Alpha plus R is equal to N2 into R. What is R? R is gamma minus beta. This is a very important equation which we need. Now again in this triangle, if you check OMN, that perpendicular which we have dropped, OMN, this perpendicular. What is tan alpha equal to? Perpendicular divided by base, MN divided by ON. So tan alpha is equal to mn divided by on. This is equal to mn divided by on. Clear? This is equal to mn divided by on. Similarly, in this triangle, mni, what is tan beta equal to? Mn divided by ni. Tan beta is equal to mn divided by ni. Last triangle is this, MNC. This one. What is tan gamma equal to? Mn divided by NC. ठीक है? Mn divided by NC. Tan gamma is equal to Mn divided by NC. Now look class, all these angles, tan, man, these are almost equal to, we are writing, when I say tan beta is this, I can say beta is this. I told you small angle approximation. Now put all the values of alpha, beta, gamma in this equation which you have received, which you made. So N1, that will be Mn divided by On plus Mn divided by gamma is Nc. This is equal to M2 Mn divided by Nc minus Mn divided by Ni. I have put all the values. Understood? Tan alpha, beta, gamma, these are almost equal to alpha. This is almost equal to beta. This is almost equal to gamma. So I have kept these values in this equation. Now, see Mn is getting cancelled. So N1. What is 1 by On? What is On? C class, what is On equal to? If you look at the figure, O, P or On, P and N, they don't have so much separation. So On or OP, this is equal to object distance, which is minus U. What else we have? We have Ni. Ni is equal to Pi. You can write On as equal to OP. Ni is equal to Pi, which is the image distance, Ni. Can you see? Ni is almost equal to Pi, which is the image distance. So this is plus V. Why plus V? Because this is formed behind it. And lastly, that NC, you can write it as PC, which is equal to radius of curvature. So in this equation, ultimately we can write 1 by C, On. So I can write it as 1 by minus U. Fine, I can write this as 1 by minus U plus 1 by R is equal to N2 1 by R Ni, no? So plus 1 by V. Sorry, minus. Here we have minus sign, no? This is the equation. Now just multiply. You have the answers with you. N1 by minus U plus N1 by R is equal to N2 by R minus N2 by V. So let's reshuffle the terms. So N1 by minus U plus N2 by V. Fine, this term I brought plus ho gaya yahan pe. And then N2 by R minus N1 by R. Clear? Now, final equation where you have to substitute sign convention. The final equation is N1 by minus U plus N2 by V is equal to, take 1 by R common, write N2 minus N1. And please put proper sign convention. Fine. Sign conventions are used over here. Clear class? This is the entire derivation, a very lengthy derivation. This is class, very lengthy derivation. And this formula is also, formula based questions are there. And this derivation can also be asked to you in the exam. This derivation comes. Spherical refracting surfaces come. See, if we change the medium, suppose if I'm talking about denser to rarer, let me just discuss this with you. If I'm talking to denser to rarer, what will be the changes? I'm not doing the entire derivation. That is a homework for you. You all will do it by yourself. What change will come? I'll give you a hint so that you can now write it. Object is here. This is N2. This is N1. N1 is rarer. This is denser. So light rays are going from rarer to denser. Denser to rarer, sorry. So denser to rarer. Here light rays are coming. Again, I'll drop a normal with center of curvature. So this becomes angle of incidence. And then refraction will occur over here. So this will become angle of refraction. Take this as alpha. Take this as beta. Take this as gamma. So this will be your object distance. Drop a perpendicular here also. Same thing. Problem is that R will be equal to beta plus gamma and I will be equal to gamma minus alpha. That's it. Your ultimate answer will be N2 by minus U plus N1 by V. The final answer that you try this question. This derivation is part of your syllabus. It's not something extra which I am dealing with. N1 minus N2 by V. This is proper sign convention will be used over here. This derivation, you will do it yourself. Fine, write it down wherever you get stuck. Let me know. write it till here, class. You people can leave once you've written. That next one, which is left, you can write it the next week.